Greetings. This is called LOF. This tutorial basically introduces to you the use of the sun angle calculator. So the way this is set up, all of the inputs are right here in red. In fact, we're not even going to use window tilt because that's not working too well on this software yet. However, we can input the city of interest, or the location, and its latitude. I'm using 28, which isn't perfectly accurate, but if you're using the base protractor for 28, this will correspond. If I wanted to be more exact, I would enter 29.7. See, and it changes it somewhat, but we'll use 28. 28 degrees north latitude, and at the moment I have a window facing true south, so its surface azimuth is 0, and morning angles would be negative if it was facing east of south. If it was facing west of south, those would be a positive surface azimuth. Again, we're going to leave the window tilt at 90 for vertical, and if we want to change the day of interest that we are looking at, that would be this blue line, then we can change the custom day designation here. So today's January the 21st, right? And that corresponds to there. Now, the black lines are day of the month, month of the year, and these crossing lines are hour of the day, with noon being here, south being here, so this corresponds to solar noon. And again, the calendar reads December, January, February, March, April, May. June is the longest day of the year. July, August, September, October, November, and December again. And for each of those lines we see sunrise, solar noon, and sunset times. This part of the spreadsheet down here is the working calculation engine. You don't need to concern yourself with that. But if you wanted to know how to find a particular day of the year, like September the 10th would be 253, right? So we could do 253, and the blue line shifts to show us the day of specific interest. But let's stick with 21. So these radial lines here indicate solar azimuth angles, and these dark gray circles indicate degrees of altitude from 0 to 10, 20, 30, 40, 50, 60, 70, 80, and 90 would be directly overhead to the single dot. If we're interested in January the 21st at what's easy time here, let's say 1 o'clock, we would see that the azimuth was about what is this, 10, 20, 30, 40, 50, 60, 70, 80, 90, so these are in 10 degree increments. At 1 o'clock the sun is about 20 degrees, call it 19 degrees west of south, so that's a solar azimuth angle of plus 19, and the altitude is about 10, 20, 30, 40 degrees above the horizon. Now, if we're interested in how that works relative to a window, okay, the incidence angle for a window that's facing true south at that time, I have my surface azimuth at 0, so the incidence angle of these dotted lines, and the dotted line, if I interpolate between 10 10, 20, 30, 40, and 50, the incidence angle is about 42 degrees. And the corresponding profile angle, the section angle I draw through the picture plane of my window, is 0, 10, 20, 30, 40 some degrees, right at, say, 41 degrees. If my window, on the other hand, faces 20 degrees west of south, I change the window azimuth and the protractor rotates. Note that I have both the incidence angle and the profile angle protractors overlaid here. On the transparency that you made, they are separate protractors, and you can read one by pointing your window arrow normal to that direction, and then turn the protractor around 180 degrees to use the other scale. So incidence angle and profile are both on your transparency overlay. Now, if I'm still interested in that, let's pick a different time. Let's do, when's the semester over? May the 5th or something? Let's say May the 15th. So that would be like 136 day of the year, right up there. And if we're looking at 5 o'clock in the afternoon, 1, 2, 3, 4, 5 o'clock in the afternoon, okay, that's this point right here, which corresponds to a solar altitude of about 21 degrees, a solar azimuth angle of about 109 degrees west of south, a profile angle of about 69 degrees, and a incidence angle of about 90 degrees. So plain and simple, that's how it works. Remember, of course, that if we were at a very different latitude, all of our answers would be different. There's 45. Some things that are worth noting here is that sometimes the sun can be behind the window. Okay? So here, for example, this line indicates a window azimuth of 90 degrees. If the sun's more than 90 degrees away from the window, it's behind the window. Okay, all these times over here, for example, are times the sun is behind this window. And it doesn't get to see the window, for example, on a June day until about 12, 11, 10, 9, till about 9:15. It doesn't even see the window on a June day. Okay, that's all.